Hello, my name is Dennis Buckmaster. I'm a professor of ag and biological engineering at Purdue University, and I also serve as a Dean's Fellow for Digital Agriculture. The topic for today is intuitive problem solving with slicker, documented, user-friendly spreadsheets. Essentially, this is a recorded workshop for you to stop, practice, resume whenever you well please. So these are the goals and the topics of today. First, I would just want to introduce features for engineers and like-minded people in science who solve problems, where spreadsheets might just be a good tool to choose. So we'll demonstrate a time-tested approach toward intuitive, logical tools for setting up decision aids. And through this workshop, you'll see things, and hopefully you'll be able to do those same things. So first, a little bit about logical spreadsheeting. I'm giving this in English, and probably all of you that are watching can listen in English. And in English, when we read left to right and top to bottom. So my argument is, why don't we compute that way? Let's gather all the inputs at the top, make it very clear. Let calculations flow from top to bottom so that our spreadsheets will be kind of boring because there won't be spaghetti flow to audit. It will be straightforward from the top to the bottom. Fight the urge to hide things. I encourage you to make everything explicit in your problem solving. There's no need to add some glitz by hiding things because some people may want to actually see what you've hidden. And you'll find out that in these spreadsheets, of course, the bottom line is at the bottom. Also thinking about how we do things outside of spreadsheets, we identify with names of people, places, and things, so let's compute that way. So instead of calling out cell references, especially C4 since it's explosive, let's call them by name. P for power, V for velocity, maybe W for weight, things like that. It makes our spreadsheets more readable, more auditable, and certainly more educational because you'll read the math much like you would write it in a textbook or in the equation that you might have written on paper. And also we can echo the formulas in the sheet itself to improve the understanding of what it is that we're computing. And then in this workshop, we'll also extend the usability, the convenience, and the power of spreadsheets with features like the valuable intrinsic functions that are built into Excel and Google Sheets, things like that. We'll use forms and data validation to constrain ranges of inputs or provide lists for users to choose from. We'll add protection to keep a user from accidentally making a change to a tool. And then a powerful tool is data tables. They allow a what-if analysis without any need to redo the math. Simply use the math that you've already generated to do problems over and over and over again. So a little bit of a warning. Of course, spreadsheets use algebra every time we use a cell reference or a name instead of the actual value. We're doing algebra. Well, spreadsheets can do far more than algebra, but at least in the workshop today, everything we're doing is algebra. The other thing about spreadsheets is they're just like any other computer code. They do exactly what you tell them to do, no more, no less, and without judgment. So they do follow directions very well. Just one warning, and that is with a spreadsheet, you'll be able to make errors much faster than you ever were able to do before. Which reminds me of one of my favorite poems of all time. You may spreadsheet in columns, you may spreadsheet in rows, but the more you spreadsheet, the more it grows and grows and grows, and hopefully it will grow on you instead of just growing in mass. And so this workshop may not be glitzy, but would you rather read some text, study some static images, and look at menu structures, or would you rather see it done and, better yet, have a chance to practice doing what it is that you see? So without much further ado, we're just going to do it. To me, this is like the open road. Give me an empty spreadsheet. Of course, in those cells, we can put text and numbers and formulas, hyperlinks, comments, and notes. We're going to set up and solve a couple problems today. And again, just a reminder that since this is recorded, you can pause it at any moment in time. Then switch to the software and try to replicate what you just saw. And so that in doing, then you will actually learn how to apply some of these tips and tricks. in this workshop file. I'm going to zoom out a little bit. The first sheet is called shaft sizing example. And so this is a classic machine systems engineering type of a problem. And I'm not going to walk through it, but you'll notice there is this text box of time-tested recommendations for good problem-solving technique, which we will implement here very shortly with a particular tool. But also, if I zoom in, you'll see there are lots of comments or notes in this worksheet that explain this top to bottom, left to right format, the value of data tables, and the way to document things. So this is a for you to peruse and read sheet, and the numbers in those comments are sort of intended to be approximately the order that you read the comments so that you understand this logical way of doing spreadsheets. Take a few minutes, maybe even if it's only 2 or 3, to look at that sheet and read those comments. Okay, here we are at the open road. And then what we're going to do is just walk through the developing of a tractor ballasting tool. In this exercise, we're going to do logical spreadsheeting. We'll show you how to do a trendline equation, some of the intrinsic functions built into Excel. We'll incorporate data validation, a couple simple forms, and incorporate protection. And you're going to see sort of a nice and tidy tool in the end. And I'm hoping that all along the way, I won't always remind you, but my goal is that you would watch a little bit, stop the video, and actually go do it in Microsoft Excel yourself. So occasionally I'll try to remind you to do that, but that's sort of on you. Watch a little bit, stop, go do it. That's the best way to learn it. So first of all, we'll just label this thing. And I don't know what you know already about tractor ballasting, but I've given you some resources. I tried to put all these reference information sort of down and to the bottom right of the space that we're going to be working on. So one nice reference is an extension publication by Taylor, Schrock, and Wirtz out of Kansas State. If you just double click that, it will open up the file. And here is the ASABE Distinguished Lecture on Traction and Tractor Performance, also for your reference. Out of that first publication, there were 2 tables, this one, and then another one down here, which we will put to use very shortly. So in the top to bottom, left to right sort of format, we're going to start with some of the input values. So the first one we're going to do is a tractor type. I'm just going to call it TT for tractor type. And just for the cryptic version to start with, we're just going to indicate whether it's tractor type 1, tractor type 2, or tractor type 3, which is either front wheel assist, 4-wheel drive, or 2-wheel drive. Later on, we'll replace that with a form, but for now, it's just a code. Is it 1, 2, or 3? Then we've got implement mount type, which is also a 1, 2, or a 3. Whether it's semi-mounted, which would be the lower links on a 3-point hitch, fully mounted, all 3 parts of the 3-point hitch, or towed, hitched to the drawbar. So again, it's a code, and we'll replace that with the form later. We also need to know the speed of operation. And let's do this in English units, so it's miles per hour and maybe something like 4.5 miles an hour. And then we're going to have the power of the tractor. PTO equivalent power of the tractor, it's going to be in horsepower, and let's just make up a number to run with, 215. Did you know if you double click here, it'll automatically format the column width to fit that? From those things, and actually let me just scoot those up just one row, just so that there's a little space before the intermediate calculations. From those things, we will be able to, with this table, which is the percent of the weight on the front axle. Actually, I didn't even label that, but that's what these are. Percent of the front weight, percent of the weight on the front axle. And then here is one that's the weight to power ratio. that's a function of how fast you go and what your tractor type is. So at some point, we're going to need that weight to power ratio, and it's going to be pounds of tractor weight per PTO horsepower. Then we'll also need the fraction on the front axle. Let's do fraction of weight on the front axle, and that's just going to be a percent. And from that, we can calculate some other things, which would be total weight target, and so that's going to just be in pounds. And then from those things, we'll later be able to calculate the target weight on the front axle in pounds, and then the target rear axle weight in pounds. So that's sort of the structure. We haven't done any math yet, but we're going to know these things. From there, we can calculate these things, and then from there, we get the actual outputs. So with regard to the weight to power ratio, first thing we need to do is go down to this table down here and realize that, well, that's a great table, but what if you go 4.5 miles per hour? Then you have to interpolate the numbers here. If you go 7 miles per hour, then you may want to be extrapolating the table a little bit. And so the best way to deal with this is to replace the table with an equation, or in this case, maybe 2 equations. Slickest way to do that is to do it via a chart. So we're going to go to insert a scatter plot. I'm just not even going to connect the dots, just insert a raw scatter plot. And depending on what you had highlighted when you do that, you might get a chart. But the first thing you should always do is right-click, select the data, and make sure that the chart is actually plotting the data that you want it to plot. So the first thing I would do is add a data series. I'm going to label the first series. This is the two-wheel drive data. And in that case, the X values are coming from here. The Y values, delete that little part, and it's going to be these 3 values there. Okay, let's add another data series, which is the four-wheel drive or front wheel assist data. The X is still the 4, 5, and 6. And then the Y column, it's the other set of data. Okay, so there's my chart. Click OK. It's a horrible chart. I didn't label my axes or anything. So this might be a part, if you're familiar with charting, you may just want to skip ahead a little bit. But I want you to go generate the chart too, so that you have it and you know where things came from when we do something in a little bit. So I am going to take the time to slick up this chart a little bit. So first of all, let's change the range on the axis over here to, instead of going from 0 to 180, let's start at 80 and maybe go to 170. That looks better. And then on the x-axis, instead of going from whatever that default was, let's, which one is it here? Axis options, instead of going from 0 to 7, we're going to go from 3 to 7. And let's scroll a little bit, see how that works. So that way that it's zoomed in and sort of at the appropriate scale. So the next thing we'll do is label the axes. So we'll add the axis titles, primary horizontal, this is speed in miles per hour. And then the vertical axis is let's see, it's called the weight to power ratio. And it has units, pounds per PTO horsepower equivalent. Okay, then if I really want to make that look a little bit better, I would take that axis label, maybe make it a little bit proportionally bigger. Control B makes it bold, make the size a little bigger, make that look a little nicer. All right, but what I really want to know is what's the equation for that? Because I'm an engineer, don't just want the numbers. There's got to be an equation for that. So the slickest way to get it is to choose one of those data series, right-click, add a trend line. I've got options for all kinds of different types of equations. Well, in this case, doesn't it look pretty linear? Just go linear. It's as good as anything. Actually, in this case, it's almost perfect, or maybe it is perfect. Show me the equation, show me the r squared. I'm done. So then I can actually click on that little equation. It is a graphic element, a text box in Microsoft Excel. So let's make it a little more useful. Instead of y equals a function of x, well, in this case, it actually has meaning. Y is the weight to power ratio. It has units of pounds per PTO horsepower. X is actually speed in miles per hour. And so I'm going to do just a little bit of slick formatting here. Go up to the font and make that units be a subscript on a variable there. And so I'm going to do the same thing here. Make the units be subscript format, just to kind of clean it up and make it look useful. I'm going to go ahead and label this. Since this equation in the blue was the two-wheel drive, I'm just going to label it as the two-wheel drive. And then, since I'm doing this, I might as well do this. Let's make that all of those fonts just a wee bit bigger. And let's also change them so that they match in color for at least those that are not colorblind. Let's have that be the same color as the trend line and the data points. So there, I've got the trend line, the data, and everything. So let's do the same thing for the other data series. Right-click, add trend line. Do the linear fit, show the equation, show the r squared. Take just a wee bit of time. It's not very much time to go ahead and slick that up a little bit. It's the weight to power ratio in pounds per PTO horsepower. This is the speed in miles per hour. Make those subscripts. Let's label the whole text box here. This was for four-wheel drive or front wheel assist tractors. I'm going to go ahead and edit the digits on that r squared. I don't really need to know that it was 0.9959. Generally, I follow the 3 significant digits rule. Don't really know that I need that to 229.17. So I'm going to lop that off at 229. And then I'm also going to increase the font size of that just a notch. And then let's color code that to also match the data series that's there, or at least close to a color match. So there is a very quick and dirty way. I don't know about dirty, actually, it's pretty clean now that I look at it. There is the set of equations for weight to power ratio for the different tractor types as a function of speed. All right, do notice there's a comment here about 160. I don't know that this is a universal rule, but it's sort of a general rule. You wouldn't want to exceed 160 pounds per PTO horsepower for most tractors. Otherwise, you're going to violate the warranty. You're going to wear out the gears and the bearings and the transmission if the tractor is too heavy. So we're going to consider that, at least for the purpose of this tool, to be an upper bound. Don't exceed 160, which really means that at some point in a four-wheel drive tractor, at approximately 3.25 miles per hour, you would reach 160. And so what we really want to model is sort of a curve that goes up to here and then flat lines to the left. In the case of the two-wheel drive, anything slower than 4 miles an hour, even though you might calculate and extrapolate a heavier weight, you would just put the maximum to be 160. But of course, if you go faster, then your tractor can be lighter and still be, at that point, power limited. So we'll try to memorize these equations. I'm sure we won't. But these are the weight to power ratio as a function of the tractor type. Back up to the tool then. If I'm over here, and then I want to calculate the weight to power ratio, it's a function of the speed and the tractor type. So that's going to require some functions. But before we do the functions, let's do the slick little define variable names trick. So that's under the formulas bar. And there's this thing called create from selection. So the quickest way is just highlight the whole sheet, which is this corner. Create from selection. Don't use the top row, use the left column. What that's going to do is call everything in row 14, it's going to refer to it as TT. And everything in row 15, it will call IMT, etc. So we just do that. It's doing some replacing because I had previously identified some variable names. But here's the beauty. Now in this formula where I'm computing the weight to power ratio, let's first do it wrong and then fix it. Well, I am remembering down here that for a two-wheel drive tractor, it's negative 25 times speed plus 260. So let's just try that. Negative 25 times, and instead of referring to C16, I can just call it S. And I'm going to use it from this worksheet, S from this worksheet, plus 260. I know what's going to happen here for me. Do you know what the problem is going to be if I hit enter right now? I did not start the formula with an equal sign, so let's edit that. Every formula in Excel must start with an equal sign. And then I knew I was going to get this because I'm working with Office 365, which is the latest version. And there is a hashtag spell exclamation error. And the fix for that is to simply add the @ sign in front of the variable names. If you don't have the latest version, you wouldn't need to do that. I'm going to go ahead and decrease the digit display there because I think to know it to the nearest one is good enough. So there I've got the formula, but that's only for a two-wheel drive, which happens to be actually tractor type 3. So this is not correct. So I need to modify this formula a little bit. I'm going to have the if function. If the tractor type is equal to 3, then use that expression. If it's not, then use a different expression. What was the other expression? You probably don't remember it, and we should scroll down and see it. It is negative 22.5 times speed plus 229. So if tractor type is 3, use that one. If it's not, use the other one. Negative 2.5 times at speed plus 229. So let's see if it works. Oh, it didn't like that. Automatically fixed it. So let's look at that. If tractor type is 3, correct. Otherwise, that one. Okay. Now I'm going to change tractor type 3 to type 23. See if I get a different number. If tractor type is 1, I get 128. If tractor type is 2, I get 128. Does this make sense? I'm going 4.5 miles an hour on a tractor type 2, which is a 4-wheel drive. What should 4.5 miles an hour on a 4-wheel drive be? Well, somewhere here, almost 130. And it's computing 128. Good. What if it's 3? Let's just double check. In this case, if it's tractor type 3, going 4.5 miles an hour, it should be somewhere almost 150. And it's 148. So it looks like it's working right. So how do we also incorporate then the notion of the maximum of 160? Well, we're just going to add on top of or around that whole if statement, we're going to use the min function. It's the minimum of 160 or the result of all those if functions. So now if I happen to tell it a type 3, which is a 2-wheel drive tractor, going really slowly, it's going to max out at 160. If I give it some higher speed, maybe I'm going to go 7.7 miles an hour, of course it starts to get slower. So how do you know? If you want to know the formula, you can put the cursor there and see the whole thing. But what I'll show more than once today is copy that, paste it over in column E. In column E, edit that. So instead of starting with the equal sign to be a formula, start with a single quote. Now what we have over in column E is an echo of what's happening in column C. C is where all the action is. E is where we make notes of what's happening over in C. So this makes it completely auditable sheet to show exactly what the calculations are. So there was one. To get to this point, we did a trend line, then we did the if function, then we did the minimum of that. This would be a good time to pause, see if you can replicate that whole piece of starting with a table and getting a weight to power ratio. But I'm going to move on. The next thing we need is the fraction of weight on the front axle, which comes from this table, which I didn't caption correctly. These are the percentage of the weight on the front axle for 3 different tractor types, coded 1, 2, 3, and 3 different implement mounts, coded 1, 2, 3. So how do we get that? Well, this looks like a lookup function. There are lots of ways to do it. In the interest of time, I'm going to first name this range, not including the labels on the tractor, but yes, including the labels or the indexes on the implement types, because that's what I'm going to use for my VLOOKUP function. I'm going to go to formulas and create a name for that range, which is those cells, and I'm going to call that range, looky here. That's the name of my table, looky here. So here's what we're going to do. We're going to go to the function wizard for VLOOKUP, because the function wizard, that little f sub x, is your friend. It helps you through the syntax of different functions. The one we're doing now is VLOOKUP, because they're going to look up vertically to find which implement and find the corresponding percent on the front axle. So VLOOKUP, what is the value that I want? I'm going fast, but you'll need to pause. And when you replicate and do this, make sure you take the time to read the fine print. The lookup value is the value to be found in the first column. Well, what I want to find in the first column is the implement mounting type. And actually, in this version of Excel, I need to also use that little @ sign. Where am I looking? I'm looking in the table that I just named. Looky here. Now, I could also go identify the ranges, but it's kind of nicer to just call it by name. And the column index number. Here's where the magic comes in. If I were dealing with a front wheel assist tractor, remembering that the table started at this 1 and ended at that 25, there are 1, 2, 3, 4 columns. And so if I had a front wheel assist tractor, I would want the second column. If I had a 4-wheel drive tractor, I would want the third column. Those are tractor types 1, 2, 3. They correspond to columns 2, 3, 4. So it's not rocket science that the column index number is the tractor type plus 1. And since I'm in the newest version of Excel, I have to have the @ sign there. And I'm going to put false here because I want an exact match. I would actually always have an exact match because I'm going to later use forms, but until then, I might not. So there we go. So let's copy that, paste it over here, change it so that you can see it. There's the VLOOKUP function that looks for the implement mounting type in the table called looky here, and the offset is the tractor type plus 1. And so let's confirm. Did tractor type 1 implement mount 3, tractor type 3 implement mount 1, is it indeed 30%? Yes. Let's try some other options. How about tractor type 3, implement type 3? It's 25%. So it appears to work. That's a great thing. So the total weight target, once I know the weight to power ratio and the power of the tractor, it's simply the product. Oops, I've got to use the @ sign in here, or I get the spell error. Okay, so we're making very good progress. Now might be another good time for you to pause and go and try to replicate all of that. So how much weight should we have on the front axle? That will be the total weight target times the percent on the front axle, so that FWA divided by 100, since that was percent up above, gave me that spill error. I just need the @ sign in there. And then the same thing here on the rear, except it's a little bit different. It's going to be the total weight times 1 minus the front weight fraction divided by 100. Oops. And there we go. So here's what other thing I would like to do. How many of us can actually measure the weight of the tractor to the nearest tenth of a pound? Nobody. To the nearest pound? Well, rarely. So I'd like to just introduce you to another function in Excel, and that's called mround. And with the function wizard, I can see here that I have the number and then the multiple after the comma. So I'm going to mround, or round to the multiple, that calculation, and I'm going to round it to the nearest 50, in this case, pounds. I'm going to do the same thing on the other one. Multiple round, whatever I computed, I'm going to round it to the nearest 50 pounds, thinking that, well, it's reasonably as close to the weight of an axle that I could get anyway. All right, so now I'm going to show you another trick. If I copy those two at a time, and then paste them over here in the column E, and then while I have that highlighted, it's either under the home ribbon, find and select, replace. The shortcut for that, you'll see there if I hover, is Control H. So I'm going to Control H, replace every equal sign with a single quote equal sign. Replace them all. I only did it in the highlighted region that I had highlighted at the moment. It made 2 replacements, and what you see is I did what I was doing one at a time before, I did them all at once. So the other thing I can do here quickly is just delete some of these rows that I don't need, sort of tighten this up a little bit. We're almost done. We have a tool that works, but it's cryptic because you have to know things about tractor type and implement type. So much better than that would be a form and also some data validation. So let's start with the speed. It makes sense to me that we might force the user to enter a legitimate and reasonable speed. So let's go to the data ribbon under data validation and use data validation to change the settings to be a decimal value as a minimum. Maybe I have something like 3 miles per hour, and at a maximum, maybe if I'm speaking of tillage and planting and things like that, certainly don't do any more than 12 miles an hour, maybe even less than that. But I'll at least let you use my spreadsheet up to 12. So I should have, if you ever have data validation, you should have an input message. So give it a title, an input message that tells the user when they're using it, what are the constraints on this cell. Enter speed as a decimal in the range of 3 to 12 miles per hour. And then, since they might enter something wrong, give them an error message. Enter with values from 3 to 12. So now, when the cursor is there, the user is going to see the message. Enter from 3 to 12. If they try to enter 13, they get an error. Please retry with values from 3 to 12. And so now they can try 4.5. So let's do the same thing on horsepower. Data validation. In this case, it seems to make sense to me that this might be a whole number. We might have a minimum. Maybe this tool seems to work nominally for, small compact tractors from 40 up to huge tractors that are 500 in horsepower. So again, you need to give them a message. and then the error alert. And then therefore we've set it to be 40 to 500. If they try to enter something smaller, they get an error. If they try to enter something bigger, they get an error. Enter something reasonable, it will work. All right, so now that was data validation. Let's review real quickly. We did logical spreadsheeting, we did a trend line, we did intrinsic functions, we did data validation. It's time for forms and then protection, and then we will, in fact, be done. Pause, add data validation, get yours sorted to this stage, and then maybe resume watching the video. I have on my Excel the developer tab on the ribbon. You may not have it. If you don't have it, here's where you get it. It's under File, Options, Customize the ribbon, and there is a spot here to get the developer tab. So if you don't have that selected, you must select it. And once you have it, it's like raising your hand and saying, I'm an expert. Let me have this tool. So now that you're an expert, let's use that tool. So on the developer tab, we're going to insert, not ActiveX controls. That requires you actually write computer code, and I don't want to do that. Let's do it the easy way. Form controls, and we have several options. Today we're just going to use the button. So here's an option button. After I choose the option button, then I can just draw one over here. Just make a small option button. And it calls it just option button 13. Well, that's a useless term. Realizing that I'm going to have a tractor option that's front wheel assist, four-wheel drive, or two-wheel drive, let's rename this one to B. Delete that text. And so now I have an option button labeled that. If I right-click on that, I can copy it. And I'm going to hit Control-V 2 times, paste, and now I have 3 buttons that are similar. Actually, they're identical, and that doesn't work. I need to change them. So I can either double-click and edit the text. The second one should be four-wheel drive. And the third one should be two-wheel drive. Now, do note that the sequence that I put them in there matters. FWA was the first one I put there. 4WD is the second one I put there, and 2WD is the third one I put there. So first thing I'm going to do is just align them. So I right-click and then hit Control and click the other 2. Then I can go to the Format ribbon and align them so they look nice. I'm going to align them on the left side, tidy it up a little bit. Also need to sort of make a mental image of how big is that, because the next thing I'm going to do is group them as one collective form. So I kind of need to see where is the limit of those boxes. So click off of it, go back to the developer ribbon and insert what's called the group box on the form controls. At this point, I need to draw a box that completely encapsulates those other boxes that were there. That's why I needed to sort of know where were the limits on those. And I can sort of double check by right-clicking and making sure that they are completely inside that group box. But I want to rename the group box to not be group box, but I want it to say select your tractor type. And so now you could choose this one, that one, or the other one. And here is the power feature. I need to right-click on one of those, and the magic is under Format Control. And the Format Control, there are lots of things you can do, but what the one you really need to control is the control, and the cell link is when you choose the first one, the second one, or the third one, where do you want a 1, a 2, or a 3 to show up in your spreadsheet? Well, if this is select the tractor type, I want the result of my form to land in C4, 14, which is where tractor type goes. Okay, now if I click off of that, and you'll see that if I check the first one, tractor type is 1, 2, or 3, and now my whole sheet works magically, and the user doesn't need to know the cryptic codes behind tractor type and implement mount type. Let's do, it's a little tedious, you'll have to watch, but let's do the same thing for the implement mount type. So back to the form controls, going to insert a button. Let's rename that one. In order, they were semi-mounted, fully mounted toad. Order is very important. The first one I put here, the second one I put there, the third one I put there are going to be coded to 1, 2, and 3. So the first one is semi-mounted. Let's right-click, copy that, paste, get 2 more, sort of put them in their places here, edit them. Second one is fully mounted. The third one is a toad implement. I can right-click, Control-click, get them all, go back to the format, align them nicely on the left end, and notice sort of the extent of those boxes. Actually, I can shrink them a little because the text was a little shorter. I see sort of where the range of that is, from right here to right here. Let's click off of it. Let's go back to developer, do the group box, grab them all, change the name, change the text there. Select your implement mount type, delete the other text. And now I can click it. It's doing something, but I didn't tell it where to report. So I right-click, format control. Where do I want the result of that form to land? C15 is the implement mount type. So now click off of it and it should work. Implement type 1, type 2, type 3. The whole thing works like magic. That was inserting the forms. Let's do the last thing, which is protection. Protection in Excel requires a 2-step process. The first is to identify when you turn protection on, which is on the Review tab, it will by default lock the whole stinking thing. What I don't want is to lock the input cells. I want the user to be able to change these. So while those are highlighted, I'll go to the home, and you can either bring down the whole formatting box and go to protection and choose unlocked. Or the shortcut is highlight what you want. Control 1 brings up the formatting, and I want those cells where the inputs, the values only go. Those I want to be unlocked. Everything else I want to be locked so that the user can't accidentally screw it up. That's step 1. Step 2 is then simply to go to the Review tab and protect the sheet. And I'm going to do it without a password. Generally, I do this. There, its password does not have a password protection. You cannot make changes anywhere in the sheet except to the parts that affect those 4 cells. So my form works because it's changing one of the input cells. I can change the speed. I can change the tractor horsepower, but I can't change anything else. That is a full demonstration from start to finish, top to bottom, left to right, documented worksheet with forms, with protection, using some chart, using some trend line, with data validation. Use this as a reminder of how to do these things. Hopefully, you can fully replicate and have a tool that works just like that. in this little virtual workshop. There's not time to walk through all the details of this particular analysis, but I want to demonstrate that once you set up spreadsheets in this top to bottom, left to right, everything labeled explicitly type of format, then you can start to achieve some interoperability or compatibility of one tool with another. So I'll illustrate with just one recent example from my teaching. This is a worksheet, the one that's named Planter. Originally was describing a chisel plow, but we altered it to describe a planter using ASAPE standards for draft requirements and things like that. You need to know a little bit behind the scenes, and that is over here on a sheet called Planter Data. We looked in the literature to sort of see the results of planting late and how much decrease in yield did you get. And sort of we essentially modeled this as sort of a flat line up until a certain date, and then after that you get a yield drop at a fairly high rate. Also, I asked one of our well-placed alumni for some price information about planters, and I came up with this particular equation. It's approximate. It's only for one brand in 1 year, but it's pretty decent. So let's go back to the planter tool. A lot of these inputs I already have set up, and you can study this on your time. But I want to make this sheet connect with another one. So first of all, in this region here, we're describing the tractor. And so I have another publication here about benchmarking tractor costs done with Dr. Elizabeth Hawkins, now of Ohio State. So what we're going to do in the planter sheet is enter in the price of fuel. How many years are we going to keep the tractor? How many hours a year does the tractor get used? Let's take these things and put them over in the tractor cost sheet. So here, instead of a length of time to keep the tractor, let's go get it from, here's how long you're keeping the tractor. Here, instead of entering the price of fuel, let's go get the price of fuel from this sheet here. And then this is the use of the tractor each year. Instead of entering it here, we will go get it over here. Then on the planter sheet, sometime below, because of the price of the planting, a certain planter requires a certain tractor, and that tractor will cost a certain amount. Well, that will then require that the prorated cost of the tractor come here. So we'll get the prorated cost of the tractor from the tractor cost sheet over here that includes fuel. Probably the most critical thing here is this is the size of the tractor that you need for this particular planter. So the tractor cost sheet in terms of the tractor power, that needs to come from here. So now I've linked these two sheets together. I do need to put in the price of the planter. So I've got to use my mental powers here to remember this price function. 11,800 times the number of rows minus an intercept. So here I've got equals 11,800 times the number of rows. Here's where I'm going to violate my top to bottom, left to right, because the width to use, which is the number of tools, or in this case, number of rows, is actually below. But that's the variable, the width to use in terms of draft. And then it was minus the intercept. I think it was 13,700. Let's go double check. Yes, it was. So there we go. There we go. There's the price function. So now I have a tool to calculate, given a planter and a number of acres and all of these things, what is my actual cost, grand total, dollars per acre to plant corn. And I did include timeliness cost, which in this, for the scenario I just painted, there wasn't any cost of planting late. Now I want to illustrate the use of a data table. Powerful, powerful tool in Excel. I've already set this up where the row of inputs in area, which is in acres, and the width, which is in feet. Sorry, it's not rows, it's in feet. But a 15-foot planter is 6 rows of 30 inches. So that's a 6-row planter, 12-row planter, 18-row planter, 24-row planter. So I've set it up specifically in this way. Here's a row of inputs. Here's a column of inputs. The intersection is what we call the setup cell. So I'll just highlight it a different color here just to kind of set it apart. We highlight the whole thing. Go to data, what if analysis. It's called a data table. It's like running a scenario over and over and over. I have a row of inputs. My row of inputs is 300, 600, 1200, 1800, 2400. It is the area to be planted. Where is the row input cell? Where would I like to take 300 and put it? 600 and put it? Well, it's the area to be worked or planted here in C4. Guess that's an explosive. It's going to blow up maybe. The column input cell is the width of the planter. Where does the width of the planter go? In C2. So watch the magic. Click OK. These formulas look a little odd. It's a special table formula, but it references the outsides of the table here. And it can, and I'll only just highlight those in a different color, so set them apart. And the content is the cost in dollars per acre, because this setup cell was pointing to the output is C62, which is the grand total of cost in dollars per acre. So let's add one more thing, and then this will just be even more magical. On the home ribbon, if I highlight the contents of the table on the home ribbon conditional formatting, I can either go green is high or red is high. Well, in this case, we're talking about price of planting corn, which I would like to be low. So I'm going to let red be high, green be low, and just conditionally format all of that to see that a dark green is actually the lowest one. And so I just want to point out, I will take a moment to just boldface the low numbers that I see in each column. It's not like that's purely optimal, but it's pretty darn near the optimal. It's the lowest value. Notice that it cost for the scenario that I have painted, $23 an acre to plant is about the lowest you can get. And here is the thing that I think is just really interesting. Optimal isn't too far from take the area and divide by 100, and that's approximately the number of rows that your planter should be to be the least cost planter. I don't know that I would take that all the way to the bank. I should revisit all of the assumptions made, but I hope that now you see the power of logical spreadsheeting. We added a data table, which is a what-if analysis, and some conditional formatting, let one spreadsheet refer to another spreadsheet that's even more complex in terms of its calculations. But in the end, pull it all together, and then I automatically had this generated. You will have to take the time to study it. If you right-click, select the data, you can see where is that pie chart coming from. But this is a breakdown of the costs for planting corn. A couple other spreadsheets are included in this worksheet file. One is labeled Integrated Model, and here is a link to an ASAB paper that speaks to this integrated model for teaching tractor and implement performance. All I want to just show in the moment here is that it's a relatively complex spreadsheet that has inputs that describe the tractor, its components, as well as the implement. And then it is an iterative problem wherein the load on a tire is affected by how much the tractor is pulling. and the amount that the tractor can pull is affected by the load on each tire and the tractive conditions. So this is a relatively complex problem that includes the tractor, its dynamics, its load distribution, the traction equations, implement draft requirements as a function of speed. Also then slip affects speed. So it's iterative in that way. But here is the tool. It's a little bit long in that it's 135 lines of code essentially, but it still is a very nice, relatively tidy spreadsheet model. So just for you to see that this top to bottom, left to right structure has application. Here's another one that's about cycle analysis. For those of you that have ever done a cycle diagram, you realize that it's extremely tedious. It takes minutes to an hour to do any single scenario, but it too can be done in a spreadsheet. So here's a reference for a publication. Here's the spreadsheet tool that you now have that's in generic units. It's a little bit metric dealing with harvest units, whether those be tons or bushels or whatever. But here's a way to do cycle analysis, which is tedious, and let the spreadsheet do the math for you. So those are a couple examples beyond the ones that we actually walked through in the workshop. I do want to, in closing, point you to another resource. We have at Purdue a site that we call the Digital Ag Resources website. Specifically, one part of that website is a Digging into the Data Pipeline webinar series. That webinar series includes some sessions related to spreadsheets, but many other sessions related to other aspects of a data pipeline. So whether you're a novice or an expert, we're reasonably confident that you'll find some good value there, and we would encourage you to check it out.